climate change? Well, the whole greenhouse effect, or global warming, stems from the greenhouse effect. And the greenhouse effect keeps our climate, lives, and economy all alive. It maintains a stable temperature at the Earth's surface, and it deals with infrared radiation, as I'm using red here. Infrared radiation, or greenhouse effect, works just like a greenhouse. Temperatures inside the greenhouse are warmer than the outside by trapping that infrared radiation. The way that it works is incoming solar energy hits the Earth, it also radiates backwards. But it gets trapped by some of these greenhouse gases that hold that heat in the atmosphere. Now if we look at the history, global warming and global cooling is not something new. We have had periods in the past where we've had the cooling and heating, or increased carbon dioxide, in the past, and multiple times. You can see that in different areas, going back so far as 400,000 years ago. And you can see concentrations of CO2 and how they correspond with the temperature. You can see they nicely fit together. As temperature peaks, so does the carbon dioxide, and so on, all the way from the past towards the future. And by knowing this, or how they know this, is scientists can take core samples and they can look at the chemistry within those core samples of ice. The farther and deeper down you go into the ice, the older it is. It froze many years ago. They can also look at fossils and look at the chemistry within that, and then also other different types of chemical process to look at how ancient climates were. But the thing about it is looking at now. And if we look at carbon dioxide concentrations in the more recent time, you can see those fluctuations that we saw in the last one with CO2 levels and temperature. But look what has recently happened to the carbon dioxide concentrations. They have exponentially grown way farther out of proportion than what we've seen at all in the past. And you can look here in more recent times, from 1974 to now, you can see this continuing of the increase in carbon dioxide concentration. Now it's kind of interesting, if you look at the concentration, it does this up-down kind of movement. And why do you think that the carbon dioxide concentration goes up and down in 1 year? Well, if you look at my globe, it might help. What do you notice about the amount of land on the north and southern hemisphere? What could you also tell me that could take carbon dioxide out of the atmosphere? Yeah, photosynthesis. I'll write that here. Doing this with my mouse. Photosynthesis can take it out of the atmosphere, so reducing carbon dioxide in the atmosphere. And at what time, or what north or south, would there be more photosynthesis? If you said the north, you'd be correct. Because if you look at the north, there's more land, so therefore more plants. So more plants, if there's more light hitting this area, which there is in the summertime, you'd have more photosynthesis, so your carbon dioxide levels would be lower. But in the winter, there is lower amounts of land. So therefore, you would have less photosynthesis, therefore more CO2 in the atmosphere. Now, causes of global warming. The main one, and also the main one with multiple environmental problems, is increased population size. As you can see, we're here at 7 billion and projected by 2040 to be at 9 billion. And with that increased population size, you also have an increased demand for energy. And how do we make our energy right now? Yeah, we burn fossil fuels. So that's also ancient sunlight. So therefore, more carbon dioxide in the atmosphere. And deforestation. So as more populations grow, you have more deforestation happening, less plants, less photosynthesis, more carbon dioxide getting stuck in the atmosphere. So the effects, broken down here, different effects from global warming. You do have melting of glaciers, increased disease, increased extreme weather, rising sea levels, mass extinction number 6, and increased international conflicts and reducing albedo and temperature increase.